Most of the steel re-rolling units use top-fired pusher-type reheating furnaces with solid, liquid or gaseous fuel. In a typical furnace, only 30 to 40% of the total heat input is converted to useful heat. Rest of the energy is lost through different areas and forms. The waste flue gas loss forms the major loss in a reheating furnace, which accounts for 30 to 35% of the total heat input. Exhaust flue gas from the furnace at a temperature of 500 to 700 degrees Celsius has a potential to be reused in the furnace. Traditionally, flue gases from the reheating furnace were let out into the atmosphere through the chimney. Thus, significant heat of the flue gas was wasted. As an alternative to the conventional practice, a recuperator, that is, a heat exchanger, is installed in the flue duct and used to recover the waste heat from the flue gases. In a recuperator, heat exchange takes place between the flue gases and the inlet combustion air through metallic or ceramic walls. Ducts or tubes carry the combustion air to be preheated. The other side consists of the waste heat stream. The system works based on the principle of physics, which says energy moves from a hot body to a cold one. Thus, in the process, inlet combustion air from the atmosphere is preheated using waste gas. The preheated combustion air is fed directly into the burner. The result is saving in terms of fuels, increase in flame temperature, and improvement in furnace efficiency. The recuperator efficiency depends on two important parameters: surface area and time available for heat exchange, and recuperator material. The impact of recuperators are that waste heat recovery up to 80% of the exhaust flue gas temperature is possible, saves fuel, reduces pollution, reduces equipment size, reduces auxiliary energy consumption. A variety of recuperator designs are available for use in rolling mills. The simplest configuration used for pulverized coal-fired furnaces is the metallic radiation recuperator, which consists of two concentric lengths of metal tubing. The inner tube carries the flue gas and the outer tube carries the combustion air to be preheated. This type of recuperator has low efficiency. To improve the effectiveness of heat transfer, a combination of radiative and convective designs are used, with high-temperature radiation recuperator being followed by convective design. This type of recuperator is also used in pulverized coal-fired furnaces and can recover up to 50% of waste heat. The third and most efficient type of recuperator is the cross-flow type metallic U-tube recuperator, which can be used to recover up to 80% of waste heat. This type of recuperator is suitable for oil and gas-fired furnace and can also be used in pulverized coal-fired furnace with certain design modifications. Every 20 degrees Celsius increase in combustion air preheat temperature leads to saving of fuel by 1%. Investment in a recuperator varies with its effectiveness. A high-efficient recuperator for a 10 TPH furnace would cost around 10 lakhs. This will lead to a saving in specific fuel consumption by 15%. Annually, a 10 TPH plant will save around 40 lakh rupees. Thus, the investment can be recovered in less than 3 months. Typically, recuperators give payback within 1500 hours of operation. The cost of a recuperator will vary depending on the material used, the surface area available, and the efficiency of the recuperator. All combustion pipelines should be insulated properly. Soot and ash deposits in the recuperator tubes should be cleaned regularly. ID fan should be used for pulverized coal-fired furnaces.